Now we move into sequences. So a sequence is defined by its nth term. So sometimes we'll tell you the words, this is a sequence and this is the a sub nth term, right? The nth term. And what that means is you'll get to plug in n equal 1, 2, 3, etc. to find out what the sequence of numbers look like. I mean, there's numbers separated by commas. And often we write sequences with these little curly Q parentheses. So what we're always going to be asked is if these sequence of numbers converges or diverges. And to figure that out, we're always going to be taking the limit as n goes to infinity. And if the limit exists, then it converges, and we'll know what its limit is. So let's just write out. I really want you to get a feel for what this is. So let's write out the first three terms. So the first term will be plugging in 1, so that would give me 1/3. That's plugging in n equal 1. The second term, plugging in n equal 2 and plugging in n equal 3, I would get this. So this is n equal 1, n equal 2, n equal 3. So a sequence of numbers is just numbers separated by commas. So does it look like this would converge to a number? Not sure. Does look like the numbers are getting closer to 1, but would have to look at a limit to make sure. All right, so let's look at this one here. 1 over 2 to the n. So if I plug in n equal 1, I get 1/2. If I plug in n equal 2, I get 1/4. If I plug in n equal 3, I get 1/8. Sure looks like those numbers are keep getting smaller and go to 0. So yeah, we'll just keep going because we'll do lots of examples of actually finding the limit, but I just want you to get a sense of plugging numbers in. So if I plug in n equal 1 into cosine of 1 is actually a number. So I would get cosine of 1 over 4, cosine of 2. If I plug in 2, 11, sorry, cosine of 2 over 11, and then cosine of 3 over 30. Okay, so if I use my calculator in radian mode, I'd get 0.54 cosine of 1. Cosine of 2 gives me negative 416 over 11, comma. Cosine of 3, negative 0.989 over 30. Oh my goodness, look at these numbers. They're going all over the place. I'm not sure if these are going anywhere, right? Then this one here, so to the 1 over n or the nth root. So put a star by that, because of the nth root, if I plug in n equal 1, I get 2, right? 2 to the 1 over 1. If I plug in n equal 2, I get 2 to the 1/2, or the square root. That's something we know of. And then 2 to the 1 over 3, so that's the cube root, right? So if I was to look at what those numbers are, so square root is like 1.4, and then cube root is like 1.259. So these numbers, I'm not sure where they're going. They're not getting that small. But just sequence of numbers is numbers separated by commas. So we could actually draw it if I wanted to, right? Okay, so how we're going to do this is we're going to go through and take the limit. So if this is the question and there's the sequence, I'm going to take the limit as n goes to infinity. And I'm going to use all that I know so far. So I know that I can use highest powers. So if I use highest powers and cancel, I get 1 over n, that's 0. So since I get a limit, that means it converges. This one here, I'm going to take the limit as n goes to infinity of cosine of 4 over n. Putting in infinity, I get 0. Cosine of 0 is 1. If I take the limit as n goes to infinity of sine of n over 3, this infinity divided by 3 is infinity. Sine of infinity, there's no limit, does not exist. Let's take a look at this one. So this is the nth root, so I'm going to rewrite it as to the 1 over n power so I can see what's happening. when I plug in infinity, I get 1 over infinity. That's 0 up here in the exponent. So 3 to the 0 power is 1. And then here, if I take the limit as n goes to infinity of arctangent, you know the graph of arctangent. So as I'm going to infinity, the horizontal asymptote of pi over 2 is what is reached.